This problem involving the sled would be considered to be a pretty straightforward problem. You notice we have a one diagonal force, so in this problem we'll show you how to handle that. It will follow the same pattern we follow with all our force problems. So the first thing we'll do is create a free body diagram. So here's the sled. It's experiencing a weight from the earth, experiencing a normal force from the snow, friction from the snow, and a tension from the rope at an angle of 40 degrees. Alright, well, as we say, the best thing we can do here is to create a free body diagram that's a little easier to work with, and that means we have to replace that diagonal. And so that would look like this. So now we have the sled and the weight and the normal. Now, instead of this diagonal, which looks like it's kind of going right and up, let's replace it with that. With a right, let's call that Tx, and an up, which referred to as Ty. And so now we see that all the forces are on either the x or the y-axis. Next step will be to really examine this triangle. So let me blow that up a little bit right here. There's the tension, which can be made of a right component and an up component. So if this is T, this is Tx, Ty, there's my angle, and angle theta. And so what you just need to get very comfortable doing is realizing that the easiest way to solve this x component is that it ends up being T times the cosine of that angle, and this y component is T times the sine of that angle. And of course it's x corresponds to cosine in this case because the angle is measured to the horizontal. We'll always be careful, where is our angle being measured from? Is it measured from the vertical or from the horizontal? In this case it was measured from the horizontal. Alright, so now we have, in this case, since we were given numbers, we could actually redraw this with numbers. We were told that this hypotenuse was 25 and the angle was 40. So working this out, this becomes then 25 cosine of 40, which ends up being 19.1, and the 25 times the sine of 40 is is 16.1. Alright, now let's do our x and y. In this case, on the x-axis now, we see, looking down here, that Tx is competing with the friction, and on the y, both the normal and the upward component of the tension are competing with the weight, equal MAY. Well, the question is, what was the force of friction? So here's the question. Here's the answer right here. So if I rearrange this, I get Tx minus F equals, well, right here it did say that it was moving at constant velocity, so that means that the acceleration is 0. So it turns out that Tx is equal to the friction, which we already figured out that Tx was 19.1. So in this case, the force of friction was 19.1 newtons.